Okay, so we already discussed what we know about quadratics. It can have 0 solutions or roots, 1, and it can have 2. We're really focused on the ones that have solutions now. So one example of a quadratic equation is something like this. How many solutions does this have? Should probably have 2, yeah? Should probably have 2. Maybe I'll make this a minus. Minus this definitely has 2. Why can I not do this? Divide by x both sides, yeah? So x equal to 5. Seems like there's only one solution. Why can I not do that? No, 5 is one of the solutions, but it ignores the second solution. No, it's not plus or minus. No. I did something here that assumed that x was not some number. What did I assume? Yeah, the other solution is 0, but when I did this, I assumed that one of the answers can't be 0 because I can't divide by 0. It isn't, yeah, okay. That's why we should always factorize these and not do this method. So if I were doing this, I would factorize out, and then I would use, what's the law called where we do this thing, where x is equal to 0? Yeah, it's called the null factor law, that these two, if two separate things multiply to give 0, then they both separately must equal 0, and we can solve with that. So we've done that in GCSE. Okay, so we're going to use the null factor law a lot, but just don't make this mistake by presuming one of the answers isn't 0. You can't be sure, so factorize first. Yeah, okay. So we're just going to look at solving some of these. So you can see that there's 3 different main types. That an example, this would be an x plus 2, x minus 2 example, where there are 2 solutions, 2 and minus 2. This repeated solution would look something like this, and they were kind of like the ones we were doing a second ago, where there's a repeated solution, and both answers are here at x equal to plus 2. And then this would have no solutions. You get something like this at the end, and you go, oh, x, no number squared gives a negative number, so it's no real solutions. Okay, I'm presuming you can do the first 2 types. So I'm just going to do the example of the bottom 2. I think this was the similar.
The A is also repeated. It could be wrong. It's also repeated.
I haven't done them yet. Yeah, it could be, yeah. Maybe I'll just do them all just so we know how to do them all. I won't presume. This one's very similar to the one we just did. Just don't bring this over here. Factor out what we can factor out. So we get x is common to both. So this is like a common factor type. And now we use null factor law. And 3x plus 5 is equal to 0. Bring the 5 over so we get negative 5. And x is negative 5 over 3. So hopefully we're happy on that. So if that's a common factor, if there's no like c term, so this is ax squared plus bx plus c. This is what a quadratic usually looks like. If there's no c term, we just factor out the x out of both these. If there is a c term, like this second one we have, x squared is equal to 5x plus 6. My first thing would be arrange it like in this general form. Bring it all over so it equals 0. X squared minus 5x minus 6. So subtract the 5x and the 6. Yeah. So we're looking to factorize, yeah. And there's different methods to factorize. You probably learned maybe there's a couple of different methods in the classroom. I like to do, okay, what multiplies to give x squared? It's x times x. What 2 things multiply to give 6? 3 and 2. And then I figure out what the signs need to be to make the above equation correct. I know that when I did my FOIL multiplication, or multiply this out, or the 2ab method, that these 2 multiply to give 2x, and these 2 will end up multiplying to give 3x as the middle 2 terms in a multiplication. So what I'm doing here is, if I have x plus 2, x plus 3, I'm slowing this down, we'll speed up in a second. x times x is the first multiplication. The second multiplication is x plus 3, x times this, so x, 3x. The third multiplication is the middle two. So these are the two multiplications, and the last multiplication is 2 times 3, 6. So I'm looking at these two middle multiplications when I do this, and I know that the signs that they need to make a negative 5x in the middle. This one makes a positive 5x. So to make a negative 5x, they both must be negative. Now there's a mistake. The 6 is negative, so one of them has to be positive to multiply to make this negative 6, which means I've used the wrong factors. I don't use 2 and 3 to multiply to give 6. I got to use something else. I got to use 6 and 1. Yes, so it didn't work the first time, so what I do in the exam is I just scrap that and I go again. X, x, still multiply. It can only be x and x. Now I use 6 and 1 this time. Yeah, so I know if I have a positive 1 and a negative 6, I'll make the negative 5. These two multiply to give negative 6. And my answer is x equal to negative 1, x equal to 6. So I'm skipping a little bit ahead there. That these will be the opposite signs when it comes to the solution using the null factor law. Okay? So just be careful we didn't go with the first thing we think of. Let's do the other two, and then we let you do a few. So we get 4x squared. I'm already rearranging it in my head to equal 0 to start off with. Now, if I have a 4 at the start here, there's two ways this could go. It could be 4x and x, or it can be 2x and 2x as my starters in the brackets. I'm leaning towards this one, but I'm not sure. I know that it's got to be 1 times 1. That's my only options. And then I got to make a 4 in the middle. So I'm thinking even multiplications rather than one odd, one even. So I'm thinking this one's probably going to work. Frank, you already knew. If they're both, I think they're, like that gives 2x, that multiplication gives 2x, and I want to make a minus 4x. Oh, maybe, yeah. Negative, negative. No? Yeah? I think that's it.
We get the same thing if you write minus 2x plus 1.
Oh, why would you put a minus 2x? You're changing the orientation of the... It should give the same answer, but you're making it more difficult for yourself, I think.
Okay.
If it works for you, go with it. I'm not going to read... This is something you may have learned already, so if you have a different method, use it. This works. So now it's a repeated root, so 2x minus 1 is equal to 0. So 2x is equal to 1, bring it over, and x is half. And it's going to be a repeated root of half. I'll do the same thing on that side, and I get the same answer. Okay, let's do the last one, and then you guys can have a little go. We have 6x squared is equal to 11x plus 10. Try and beat me on this one if you want. I'll pause for a second, and then I will do it. So remember, my starting point is to get a look in this general form here. So that's my first thing I'm going to do. I'm going to bring everything to the left-hand side of the equals. There's a number of ways I can go here with the 6. There's 3 different ways, I think. From experience, if these numbers are not too large, and this number is bigger than hoped, try and split this up into 3 and 2, I think, rather than 6 and 1, because 6 multiplied by something here might give too big an answer, but I don't know for sure. But that is my logic. I'm going to go 3x and 2x, and 1 is odd, 1 is even to get an odd number in the middle. That's all I'm thinking. And then I look at 10, I go, right, let's not use 10 and 1, because I don't think that's going to work here. It's possible, but I'm going to use 5 and 2, and then hope for the best. The 5 goes with the 2. 5 goes here with the 2. So that'll be a 15, and that'll be a 4, and that seems logical. The 5 and the 2 go like that, so 2 times 5 gives the 10. Then I just work on my sign, so that's a 4x. You don't have to do this step, but I like to do it. That's a 15x, and I want to make minus 11x. So if that's negative and that's positive, that makes minus 11x. And they're opposite signs, so that'll work with the minus here. So minus and plus here.
-2/3 and 5/2.
Yes. Okay, so x from this, if I let this equal to 0, that's